Good morning. So this is lesson 1.1.5. Maybe you've been set up. So our book says, does this sound familiar? Sometimes you're given a scenario to investigate. You understand the scenario. You understand the question. You just have no idea how to set up the problem. If someone would just set it up for you, you could solve it. So when that happens, I've got 3 different scenarios, 3 different kind of not famous, but popular problems that occur in pre-calculus. And we're going to go over them today. The first one is in your book. It's section 1-40. So it says the volume of an open top rectangular box is 4,500 cubic centimeters. So if we just had a picture of what that was, try to draw our open top box. So it's maybe if you've bought shoes and the box has the lid that's completely separate and the lid just fits down over the box. Well, the bottom of the box, that's the open top box. So it's just the shoe box, the bottom part where the shoes are, not the top. So let's see. The volume is 4,500. Let's just write down important things. The length of the rectangular base of the box is twice its width. So the length is twice the width. What height will make the surface area as small as possible? So if we want to make the surface area as small as possible, we want to minimize the surface area. So sometimes it helps to think about the words in the question as, what's the mathy way to say it? Make it as small as possible means to minimize it. And minimize it, we think about relative min and relative max. And a graph that has a relative minimum, there would be the minimum right there. So it might be a parabola. Could be another type of function. So now we need to try to put this in terms of algebra. I know the length is twice its width, and I'm trying to find the height. So what we might do, so if the length is twice the width, we might let the width be x, and then the length would be 2x. So my length is 2x, my width is x, and I'm trying to figure out this height right here. Okay, let's now think about some formulas that we have. If the volume is 4,500 and this is a box, then the volume of a rectangular prism or a box is length times width times height. And let's see what all we know. We know volume. I'm going to drop my units for now. We know length is 2x. We know width is x, but we don't know height. So let's simplify that just a little bit. When we multiplied those like bases, those x's, we added their exponents. And now let's think about surface area. Surface area is the area of every surface. So if this is an open top box, it's got a bottom. So I don't know where I want to do this. See, I'm just going to erase this and try to put my areas up here in this top corner. So we've got the bottom. The area of a bottom, it's a rectangle, so it's just length times width. And then we have the front panel of the box, which it's length times width, so it's 2x So if we're looking here at this front, we're talking about 2x and h. So it's 2x times h. Well, the back would be exactly the same. It's also 2x times h. So there's two of those. The left and right side is x by h. And the other side is the same. My Apple Pencil died for a moment. I believe we were just getting ready to talk about the area of that side, which is also x by h. That means we have two of those. So there's only one bottom because it's an open top. So there is no top. There's a front and a back, and there's two sides. So we've got 1, 2, 3, 4, 5. So that's our surface area. So our surface area is 2x squared, the bottom, plus 2 of these. So let's go ahead and multiply that out. That's 4xh plus 2 of these. So that's 2 more xh's. So our surface area is 2x squared plus 6xh. Okay, so now we are down to two equations. And we're trying to minimize the surface area. So the surface area is our main equation that we want to try to deal with. So for the volume equation, we're going to, we could solve it for x or h. I'm going to choose to solve it for h. So we've got 4,500. Well, let me show. Let's divide both sides by 2x squared to get the h by itself. 4,500 divided by 2 is 2250 over x squared. So that's our h value. So we could take that h value and we could plug it in our surface area equation. So it's multiplied by 2250 over x squared. I'm running out of room, so we're going to multiply 6 times 2250. Hope I did that right. And then I have an x in the top and 2 x's here in the bottom. So that's really just like x over x squared. So that would leave 1x in the bottom. Now this is the function that we want to minimize. This is the function that we're going to put into our calculator. So go ahead and grab your calculator, go to your y equals, and let's put in 2x squared plus, you either need to do the fraction by going alpha y equals, or you need to do, well, it doesn't matter, 13500 divided by x. We don't have to be too careful. Both parts of that fraction just have one piece. And then you hit graph. And it might be that you don't see your entire graph because your window might not quite be right. So you might be able to do the zoom fit choice. So hit zoom and oh, I have the older calculator. I might be able to zoom out on mine and hit enter. I still don't see that parabola shape, which I should see. Let's see. going to change my window. I'm going to make it really large. Okay, so through a lot of patience with my calculator, I found a window to where I could see the graph, and I set my minimum for x at negative 100. I set my max positive 100. I just let my scale, what I chose to count by, stay at 1. And let me erase this down here. Set my y-min at, I think I told some of you, my calculator's a little messed up. It got damaged over the summer. I think that looks like negative 1,000. My y max, positive 1,000. And the y scale was 100. This would be probably easier if you used Desmos graphing to help you. You could probably zoom in and out a lot easier and see what was happening with this graph and figure out what you could set your window to. But when I did that, I have this graph. I'll try to show you the steps that I'm doing. We'll see if this works. We want to minimize it. And this is the point right here, which will be my minimum. Now, it's true that we've got this portion of the graph, but it's a negative x value. And if you remember in our problem, x is the length of a side of a box, so it can't be negative. So we're going to go to second calc. We want to minimize it, so we'll choose choice 3. Sorry, I'm a little shaky. And then it gives you a choice. It says, what's the left bound? So you're going to arrow until you find your little x. And then I want to try to get just as close to this minimum point on the left side of it. So when I get to the left of it, I'll hit enter. And then it's prompting me, what's the right bound? So you want to arrow with your left and right arrow. Get just a little bit to the right of that minimum point. And hit enter. And then it's saying, what's your guess? Where do you think it is exactly? So you arrow over right where you think the minimum is, and you hit enter. And when we all go through those steps, we will all get the same answers. So the minimum, I've got lines on my calculator right where I need to see. But the minimum x looks like 15.000002. So let me switch back to my screen. So the x value was 15. That's the x we're looking for here. So it's a length that's going to minimize it. So we're going to say x equals 15. So we can go to our surface area and plug our 15 in. Actually, I just reread the problem, and the problem did not say find the surface area. It said what height will make the surface area as small as possible. Well, we know this x value is the one that's going to minimize the surface area, because this is what our y was on the calculator. But they want to know the height, so we're going to go back to this equation. So we will know the height that minimizes it when we plug 15 right here. So it's 2250 divided by 15 squared, and looks like it's 10. So 10 is the height that will minimize our surface area. I might not do all three of these. That took a little longer than I meant for it to. So we're going to look at 1-42 next. Farmer Jinzu has 300 feet of fencing to enclose 2 identical rectangular pens that share a common fence. Then it says A part, what are the dimensions of the pins that make their areas as large as possible? Well, it makes sense that the farmer would want the area that he's fencing to be as large as possible. Maybe he's going to let his cows pasture there and he wants them to have as much grass as possible. Or maybe he's going to plant something in the ground and he wants to be able to plant as much as possible. So it makes sense. Let's see if we can draw a picture to help us out with our problem. We're going to enclose two identical rectangular pins that share a common side. So here's our rectangular area that we're talking about. And we want these two pins to share a common side. So here's one, here's the other. And they've got that one side in common. We know that he has 300 feet of fencing. So what's he going to fence? He's going to fence along this. And he's going to have to fence that common side. So we could say that's the perimeter. So we know the perimeter is 300. But it's not the perimeter of the entire large rectangle. It's the perimeter of the two put together. But when we find the area perimeter of this one, let's go ahead and put some letters up here. Let's do length times width. And then this would also be a length, and this would also be a width. And then when we go over to talk about this rectangle, we have length times width. And we have length, but we don't need to fence this line twice. So we'll just be using one width. So when we discuss the perimeter of this problem, we have 1, 2, 3, 4 lengths, but only 1, 2, 3 widths. So we can't just do that perimeter formula for a rectangle 2L plus 2W because our problem's a little different. So we're going to fence this piece right here in the middle. So that's our perimeter. Plug your 300 in. So that's as far as we can get right here. Let's go back and read the problem now. What are the dimensions of the pins that make their areas as large as possible? So last time we were trying to take the wording and make it more mathy. So if they want to make it as large as possible, they're wanting to maximize it. So we want to maximize the area. So area is going to be an important formula. Area of a rectangle is length times width. But for our problem, I've got this problem kind of crazy looking. So the area of the two pins put together is the area of the whole big rectangle. So the length of the whole big rectangle is L plus L. So it's 2L times the width of the whole big rectangle is just W. All right, so now we've got two equations and two unknowns. And just like before, we had to choose the equation that we'd be working with. They let us know that by saying they wanted to maximize the area. So this is the problem that we'll be putting in our calculator. So this equation we can use to solve for L or to solve for W. It doesn't matter which one. I'm going to choose to solve for W. So I'm going to get W by itself. If you've never done these before, they feel awkward. But then when you've practiced them a few times, they start to feel a little more comfortable. Let's go ahead and let's just leave it like that. So W is, so we're going to take this W value and we're going to plug it in right here. Let's see if we can simplify that a little. 2L times 300, 600L, minus 2L times 4L is 8L squared, all over 3. Now you can choose to divide both of these by the 3 if you want, or not. It's totally up to you. I think I'm just going to leave them as they are. And we're ready to go to our calculator. We're going to, A is my y equals. And the variable that we're talking about is L, but we'll just use the X button as our variable. And we'll plug it in. Okay, I'm going to try to show you my calculator screen like I did earlier. So this is how I inputted it into my calculator. Might have been easier if we divided by the 3 and had 200x minus 8/3 x squared. But as long as you put your whole numerator in parentheses, we're good. And then I'm going to go to graph and just hope it shows up. And from the last settings that I shared with you, they actually worked for this one too. So that was nice. Now remember what we're trying to do. We want to maximize the size of these pins. We want to maximize the area. And this is a parabola that has a maximum. So we just want to calculate that maximum. Sorry, I'm all shaky. Try to push these buttons with my left hand. So we go to second calc, maximum. And again, it's saying what's the left bound. So let's use our left and right arrow keys and find where that little x is. Go a little to the left of the max point and hit enter. Now it's saying what's the right. So arrow over some more, a little to the right and hit enter. Now it's saying make your best guess. So I'll try to get right where I think it is and hit enter. And my calculator's so messed up. I think it says 37.5. Yeah, double checked with the book. So we're going to deal with 37.5 as our x value. That's our L. Now let's go back, now that we've done that, and let's read what they want us to do again. What are the dimensions of the pin that make the area as large as possible? Well, we know the length. The length is 37.5. And how do we find the width? Let me just circle that so we don't lose it. Well, over here we had this width formula already solved for W. So all we have to do is put our length value in, figure out what W is. And when you go to your calculator and figure that out, 300 minus 4 times 37.5 is 150, and 150 divided by 3 is 50. So 50 is the width, and 37.5 is the length that will maximize these pins. B part says, if X represents the length of the enclosure, what is the domain in the context of this situation? So they're saying, remember, domain is X values. So what all X's are going to make sense in this situation? Well, none of the negative X values would make sense because we can't have negative lengths. 0 doesn't make sense. So I would say the domain is all the x's greater than 0. Now, let's think about that a little bit more. How long am I physically able to make this fence? Well, I only have 300 feet of fencing. And whatever the length is, I'm going to need that length for the top and the bottom of the fence. So however much we use, we're going to need it for this and this. So we're going to have to split that 300, at least 150 and 150. And if we did that, there would be nothing for the width. But that would be a a quick way to think about the domain. The domain would be all the x's between 0 and 150. Can't use 150. We can't let it be less than or equal to, because if it was 150, there would be no width at all. So that would be great too. Interval notation, we would use parentheses for the smallest to the largest value. And we use parentheses and not brackets because we can't include 0 and 150. Okay, I think we'll stop there for the day. Please, 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 if you have things that bothered you or worried you or were confusing about this video lesson, ask me Wednesday. All right, thanks. See you Wednesday.